give you a quick talk about natural language processing. Okay. So you remember last week Pete sent around a list of papers that would be good to read. So I've taken one of those and read it, and this gives a summary of what it says, of my understanding. Now, I'm quite new to natural language processing. This is the first bit of information I've read about it. So just to give you a bit of an introduction to it. So when I'm thinking about natural language processing, the scenario I've got in my mind is job applications. So I'm a contractor. Every now and again I do search job boards. And what I like an AI to be able to do is to be able to look at a job application and tell me whether that's a good one for me to apply to or not. Okay? So just to give some ideas about what that might mean, one of the things you often see on job applications is security clearance. I don't have security clearance. So therefore, this is an example of something where if it wants security clearance, it's no good for me. Okay? So here's some example sentences you might see in a job application. Now, a typical way you do AI is use a bag of words approach, which if you've done the course through a course, you will know that you're just looking through the words, and if it's got the word in there, it then makes some deduction based on it. But obviously that's a good start, but all these three sentences would mean that the job is taken out of consideration, but actually they mean completely different things. So the first one, must have security clearance, obviously that job's not for me. Second one, security clearance is desirable, that means that job is probably not for me because I don't have security clearance. There's a third one, does not need security clearance, obviously, yeah, that's great, I go for that job, okay? So this is an example of the type of thing that I think this piece of software is trying to do. That instead of just doing a bag of words approach, what this paper is about is trying to understand the sentence, to work out what it actually means, so you can actually deduce from it, whether it's what the relevance of it is. And I think that you would then have to put that into another bit of AI to actually interpret the results of, because though it may work out that this means you don't need security clearance, you'd obviously need another bit of AI to work out whether you're interested in security clearance or not. Yeah. So that's my understanding of what this paper is trying to do. And obviously I've given some really simple examples. Here is what you typically see on a job application. You'll often see like a desirable and you'll see a bullet pointed list of things, and it's not actually in sentence format at all. I don't know whether this bit of AI would understand a sentence of this format, where there isn't really a sentence or a verb or anything, it's just a list of things but you need to be able to know, you've got to look back in time to read the desirable heading to work out that this is essentially the same as that sentence there. Okay? So that I think is the background to what this paper's trying to do. Okay? So they give a lot of different types of natural language processing tasks about how you might try to understand those sentences. Okay? New to me. So what part of speech tagging? So that means you're trying to work out whether something is a noun or an adverb or something, a basic role, which is obviously quite straightforward because obviously you can just look up a list of words. Everyone knows that, I don't know, glass, that's a noun. You don't need to, it's not much AI. Chunking is where you're trying to split sentences up. Named entity recognition means that if I said glass, then you know that's a type of, it's something to do with the kitchen. So it's understanding what type of things are. But the key thing this paper's trying to do is to do what I was saying earlier, to try and not just work out which things are nouns, but to try and work out, it's got all these kind of special classifications in it, which I didn't really follow. But I think what it's trying to do is work out which is the subject of the sentence and which is the object, and to split it up. And they've got an actual syntax for much more detailed understanding of how you classify the different words. But you're trying to split it up into its various parts, okay? Because obviously, if I said, John hit Pete, if you just worked out which are the nouns and which are the verbs, you'd understand some fighting had gone on, but you wouldn't really understand what happened. You need to understand that John is the subject, Pete is the object, is that right around? So it's very different to saying Pete hit John from a point of view of what happened. And just having a simple understanding of nouns and verbs isn't really enough. So this is trying to work out, this one's got John ate apple. So you're trying to work out that obviously it wasn't apple that ate John, it was John that ate the apple. And you need to work out which of the two ones they are. And that's what this machine that they set up is trying to do. Well, if I go down to this this is the architecture, and I think I've 90% got what they're trying to do. I'll tell you my understanding. I think I haven't quite fully understood it. So they come up with quite a complex architecture. So I've worked obviously with neural networks. We've got 3 layers. Well, they've got a whole, I don't know how many layers they got in there. But the way they're working is they take a sentence, and for each sentence they give it various features, and the only features that they've got is the capitalisation of that feature. So if that feature had a capital word, first letter was capitalised, they'd put it as a 1, I guess. And if it was all lowercase, they'd put it as a 0. Okay. So you have basically put, and then the other feature they've got is that they then have a dictionary of words. They translate each word into a number, which is the dictionary number of that word. So you put 2 features in. One is the number representing that word, and the second is was it capitalised or not. They then go through and they look up a list of parameters, as it were. So each word is a list of features that relate to that word, which themselves are meaningless. They're actually learned by the AI. So I think what they're trying to do is they're trying to get the AI to learn what words are nouns, and so that becomes a feature, and verbs and adverbs, and that becomes a feature, but it's not that they're telling the AI that, it's actually learning it itself. So you end up with these lookup tables, but they then go through quite a complex AI. I've only just started to look at convolution AIs, so what they're doing is they're effectively putting this as a matrix. So each of these is each word, and then each of those is the different features that they've learned for that word. So you end up with a matrix of it's n words, and they're k features. So it's an n by k matrix, effectively a grid. And then they put that whole grid into the next layer, and that does a convolution. And basically what that's doing is summarising, it's looking over a section of each of the matrix, and it's doing some sort of filter on that section to produce another layer of features. Okay. I don't know. Convolution is new to me, so I gave an example of a convolution. It's more done in image processing. So what you do in a convolution, you take a grid of the picture, and then you put a filter across it, then to derive a lower resolution version of the picture, and the filter will lose some of the data, so it's basically summarising it. So this is a picture you might want to analyse, and these are 2 convolutions of that picture that you might want to put into your AI, and they're obviously highlighting. This is highlighting the borders of the colours, so the light. Looks like it's highlighting the darkness in the picture. That can then be used for further down. So it's like a summary of the picture. So if I go back to my, so this is effectively summarising over the words the interesting features, and you can see it does various different summarisations, which then produce the different features. It's then summed together the maximum over all those features for each of the individual features, and that's then gone through a classical neural network. So quite complicated. Okay, I was hoping I'd be able to. If I had more time, I'd try and build this network, but then I looked at it and thought that's actually not that easy to build. Okay, so. I didn't look at TensorFlow because that does have convolution there. So actually, I say it's more difficult. It might be something you could build with a bit more experience than I've got relatively quickly. But it's not something could do that in a week. Right. So what was the interesting? Okay. The other thing I should point out about this is that. So I said there was 1 feature. There's actually 2 features because they run this neural network for each of the words. So they also pass in a feature to highlighting which word in the sentence they're actually interested in. So at the end of it, what you get out is a what they call a soft max, but it was a 1 versus many, wasn't it called in the course?
Is it 1 hot?
1 hot, I think. So you basically want a 1 for one of the classifications and a 0 for all the rest. You're trying to classify into
1 hot.
1 hot.
Yeah.
Okay. Thanks. So you're trying to classify it. Okay. So. But the interesting things I thought that the key learnings they got from this, right, is that what their theory was is that having built this complex machine learning, rather than just trying to get to learn 1 task, they're actually going to use it to teach it all the different tasks of natural language processing from the very beginning. So it's going to be the same network, but it will be used for, what was it called, chunking, part-of-speech tagging, named entity recognition, semantic role labeling. And the reason they did that is they use the same network for all of them, is that some of these are much simpler than others. So for example, part-of-speech tagging is something you can probably get some data for quite quickly and start training on that. And you can then they want to then use the network they trained on this to then try and help them with that.
So keep all the weightings.
Sorry?
Keep all the weightings.
That's right, keep the weightings. So it's actually if I go down, they won't be able to keep all of them. They've got some, where's it gone here? So they got the idea that they'd have several lookup tables, of which one will be shared and some would not be shared. So when I said that for each word had a set of features, what they're effectively saying is like the top part might be a shared features, and then you might have some more features further down which are specific to that particular network. So you might build up some shared features about the words which you could then use on other networks. Okay, so that's their key insight, I think, in this paper. So they go on a bit of detail about that. So for example, the reason why this might be useful is that you can quite easily get unlabeled data from Wikipedia of lots of English language text. If you train an AI on Wikipedia and then use the same weightings for a much more specific task that you want to use it for, and obviously that's a quick way of getting lots of data. Yeah, does that make sense? So if I go down to the bit I want to show you. So having said that that's what their approach wanted to be, they then did some graphs about how it performed. So this blue one is where they used the same network for lots of different, all the different types of classification they may want to do, and they found that performed much better than the other red ones, which is where and the other colours, which is where they only did one particular type of problem on it. So this blue one is where they shared the weightings between all the different problems, whereas the other colours are ones where they only trained the network on one particular thing or two particular things. So they found that by sharing the weightings among lots of different problems, they got a much better performance. Okay.
So a quick question.
Yeah?
What does that say on the y-axis? Is that total entropy?
Sorry, this is test error.
Test error. Ah, okay.
So this is the percentage of words that were incorrectly categorised.
Cool.
Yes, I should point out. And this is the number of training runs, which they call epochs.
Yeah.
So, which I think is a batch of training runs. It's not just an individual training run, because they're using stochastic training, which is you run a certain set of trainings, different sessions. Okay.
Okay, thank you.
So, right. So I think that's about as much as I got from this paper. My next step would be to try and build it to see if I can understand it. But I think from my takeaways I took from it, it was an interesting idea that you could share parameters between areas. So the idea you might, I don't know, you might have LV and Canford and Minerva all their own house views, but you might be able to share some of the data. I don't know if that would apply, but it was just sort of something that seemed like an interesting way of approaching it. Okay. I was a bit disappointed by the error rate, because if I go back to that, you can see that their best model performed as low as 14.3% in per word error rates. That means they only got an 86% success rate on classification, and they said that compares with the best ones from other systems, which might get 16%. I'm new to natural language processing. That sounds pretty poor to me in terms of actually getting a live system. I don't know if that's good or not, whether that's because they got particularly difficult problems or what. But
so the error rate is 14%, so the accuracy is 86.
86%. Yeah.
I
don't know if
that's pretty good, isn't it?
I don't know, it's decent, but yeah, you
I don't know how to
kind
measure
of hope
that.
it would do better, wouldn't you? Hope for 90 something, wouldn't you? So
it'd be interesting to see where the errors are. Are the errors edge cases, or is it making that kind of error across even pretty standard English?
Yeah.
Exactly. Yeah. So I didn't know how to take that, because it seems like a high number when you look at it. But does that mean, like, if you had a conversation with someone over the phone, it means that it will only understand 86% of what was said, and you might find there's probably a lot of repetition, because humans don't understand everything that people say. So 86% might actually turn out to be 90% of the information or something. but I wasn't really.
Do you know what the size of their data set was?
Well, they use different data sets for different tasks, so you've got
Right.
the training all sorts of different things. They use Wikipedia as, for example, of sentences, which has got something like 600 million words.
Right,
So
so
it's a huge,
massive,
massive
then.
data
Yeah,
set.
okay.
But then for other tasks, they used data sets of maybe 40,000 words.
Right.
So things like the part of speech, there's a standard data set available on the internet for that's all labelled up already, which you
Oh,
can
cool.
put into natural language processing. So some things are much smaller data sets.
Right, okay.
Right, what's the other thing? Oh yeah, so, but I was interested that potentially out there are standard natural language processing systems which will then give like a set of features which you could then use for your own AI. Because that's what I think seemed to be where they were going with this, is that, that part of speech, semantic, whatever they're trying to do, semantic something learning, isn't really that useful on its own. You really want to use that to drive something else.
Yeah.
But the fact that I've assumed that this means that maybe we could get an off-the-shelf package or something where someone says, well, I've trained this network to identify parts of speech in English. So you'll then get it out of this. You put in a sentence and it'll come out and say, right, that's the object, that's the verb, that's the subject. You can now put that into your own AI somehow and then do some more interpretation on it. That's my understanding of the paper. That's what I got out of it in a week.
Great.
Any questions on it?
Yeah, thanks a lot.
Fantastic.